Okay, so the first one is not trivial, right? And so we get the solution for it in terms of t. What is that?
x1 minus t, x2 3t, x3 minus t by 2.
And x4
Assume to be t.
assumed to be t. Please tell me again.
x4t,
Huh?
x3 minus t by 2,
Huh?
x2 3t,
Okay.
x1 minus t.
Correct. Right. Fine. And what about the second one? Non-trivial. So roots are.
t 14 minus 1t.
This comes out to be non-trivial. X plus 2y plus 3z, 2x plus 3y plus z, 4x plus 5y plus 4z, x plus y minus 2z. What is the rank?
3.
So, how many variables are there? Equations are 4, variables are 3. So, it has a trivial solution. How will you get the solution for it? There are 4 equations, no doubt, but variables are only 3. It is number of variables equal to the rank, then the solution will be trivial. Right? I had given it purposely, that's why I again cross check. Because if there is a single digit mistake, then also the things will change. Now, the next type of problems, where we are required to find out certain conditions so that the system will be having trivial solution or non-trivial solution or something like that. The problems are like this, say. Yeah. Investigate for what values of a and b. Investigate for what values of a and b the system of equations 2x minus y plus 3z equal to 2, x plus y plus 2z equal to 2, and 5x minus y plus az equal to b. So we are given these 3 equations which contain 2 unknowns a and b, and the question is under what conditions this will have no solution, unique solution, infinite solutions, and so on. So all the cases are to be examined for different values of a and b. Of course, procedurally we will start with the augmented matrix, and it will be 2 minus 1 3 2, 1 1 2 2, and 5 minus 1 a b, and obviously the first step will be r12, 1 1 1 sorry 2 2, 2 minus 1 3 2, and 5 minus 1 a b. It is r2 minus twice r1 and r3 minus 5 times r1. 1 1 2 2. This will be 0. When you subtract it twice, it is minus 3. Subtract it twice, it is minus 1. Twice minus 2. Subtract it 5 times, 0. Subtract it 5 times, it is minus 6. Subtract it 5 times, so it will be a minus 10 and b minus 10. Fine. Now to make this 0, it will be r3 minus twice r2, and so I will write it here. So it will be 1, 1, 2, 2. 0, minus 3, minus 1, minus 2. It is 0, 0. If this is subtracted twice, means it will be added. It will be a minus 8. And if this is subtracted twice, so again it will be added. It will be b minus 6. So we end up at this position. Now see, if a is not equal to 8 and b is not equal to 6, then row of a will be 3. Row of AB will also be 3. And therefore row of A equal to row of AB equal to number of unknowns n. Therefore unique solution. Right? Simple, straightforward. Now just tell me, okay, even if this condition is not there, if A is not equal to 8, still this is true. In that case, last value Z will come out to be 0, but it's a unique value. So we don't require this at all. It is only under the condition A not equal to 8 we will have this situation. This is one case. Second, if A equal to 8, because not equal to 8 condition is done. So if A is equal to 8, then what will happen? Row of A will be 2. Now row of AB will depend on what is value of B. So there are two situations. Under this case, row of A is 2. In this, if B is equal to 6, then row of AB will be also 2. And we will have the case that row of A equal to row of AB is less than number of unknowns, therefore infinite solutions. Right? And the second case, if B is not equal to 6, then row of AB will be 3. And as row of A is not equal to row of AB, there will be no solution. Got it? And we don't have to solve. It is just to investigate. Got the cases? This somebody writes, but that is not required. If A is not equal to 8, this rank is going to be equal to 3. Both of them. Right? A equal to 8 mein there are two cases. B equal to 6, B not equal to 6. Right? And he has asked no solution, unique solution, infinite solutions. Yeah, done. Got it? And a few more similar problems. So this was first one. I will give you two more. Job to be done is just the same. It is 2. You can take down this. Seven x plus 3y minus 2z equal to 8. 2x plus 3y plus lambda z equal to mu. So it is lambda and mu. Different cases. But what happens?
Lambda is not equal to 5.
So lambda is not equal to 5.
Unique solution.
Unique solution. Then?
And lambda is equal to 5, mu is equal to 9. Infinite solution.
Okay, and not lambda equal to 5, mu not equal to 9.
No solution.
No solution. Right. He says it is 3x plus 4y plus 5z equal to alpha, 4x plus 5y plus 6z is equal to beta, and 5x plus 6y plus 7z equal to gamma. He says that these equations are consistent. It is proved that these equations are consistent if alpha, beta, gamma are in arithmetic progression. So now the variables have increased to 3. We can clearly say that this is in AP, this is in AP, and this is also is in AP. So this has to be in AP, but we will have to prove it. So we start with the augmented matrix. It is 3, 4, 5 alpha, 4, 5, 6 beta, 5, 6, 7 gamma. Now, if I subtract this row from these two, many things will be simple, right? So it will be R2 minus R1 and R3 minus R1. So it becomes 3, 4, 5 alpha. It is 1, 1, 1 beta minus alpha, and 2, 2, 2 gamma minus alpha. Next, should I interchange R1 2? So it will become 1, 1, 1 beta minus alpha, 3, 4, 5 gamma minus 9 alpha, yeah, alpha, and 2, 2, 2 gamma minus alpha. Then it will be obviously R2 minus 3 times R1 and R3 minus 2 times R1. So it is 1, 1, 1 beta minus alpha. 3 times subtracted, this will be 0, this will be 1, this will be 2. It is alpha minus 3 times beta minus alpha. We will calculate it later. Subtract it twice. So this is 0, 0, 0. It will be gamma minus alpha minus 2 times beta minus alpha. He is talking about consistent. We have already got that rho of A is 2. And so rho of AB must be 2 for consistency. And if rho of AB is to be 2, then that gamma minus alpha minus twice beta minus alpha should be 0. So it is gamma minus alpha minus twice beta plus 2 alpha equal to 0. And what do we get? Alpha plus gamma is equal to twice beta.
Direct
How?
2R2 minus R1 minus R3 तर ते मधला रो पुन्हा 0 होऊन जाईल आणि इकडे 2 बीटा.
See, what we want to do is we want to make the lower triangle 0. I can make this row, I could have subtracted here also. But our procedure is what? Make the first column lower element 0. So I am just following the procedure. There can be other tricks also. But from this, can you conclude that this is in AP? Yeah, that is the property of the arithmetic progression. What arithmetic progression is, if the first term is a, next term will be a plus h, next term will be a plus 2h. And the property is middle term, twice the middle term equal to first plus third. And so we say that therefore alpha, beta, gamma are in AP. This is the property itself. First term plus third term is twice middle term. Right? Make a note. This was third problem. Fourth one will be again prove that. Shit. Sorry. It was the same problem with alpha, beta, gamma replaced by ABC. And he wants us to prove A plus C equal to 2B. So both तो नहीं करेंगे, right? Yeah, we'll do this. Fourth. X plus Y plus Z equal to 1. 2x plus y plus 4z equal to k, and 4x plus y plus 10z equal to k square has infinite solutions. Find k and corresponding solutions. That is the next problem. Now to solve this problem, augmented matrix will be, it is 1 1 1 1 2 1 4 k and 4 1 10 k square. So it is R2 minus twice R1 and R3 minus 4 times R1. It is 1 1 1 1. This is 0. When we subtract twice, this is minus 1. This will be 2. When we subtract it twice, it will be k minus 2. And it is 4 times, so it is 0 minus 3. This will be 6. And 4 times subtracted, it is k square minus 4. And then using R2, I can make this element 0. And for that I will have to perform something like R3 minus 3 times R2. So it is 1 1 1 1 0 minus 1 2 k minus 2. This is 0, this is 0, this is 0, and it will be k square minus 4 minus 3 times k minus 2. Right, and so, but it is given that it has infinite solutions. That means given that rho of A equal to rho of AB is equal to 2 is given. Infinite solutions given. It has to be less than 3. Therefore, k square minus 4 minus 3 into k minus 2 should be 0. And so we have k square minus 4 minus 3k plus 6 equal to 0, or k square minus 3k plus 2 equal to 0, which is nothing but k minus 1 into k minus 2 is 0. We have k equal to 1 and 2. And that's why he says find corresponding solutions. So we will have one solution for k equal to 1, one solution for k equal to 2. Right? So at k equal to 1, what would be the equations? X plus y plus z equal to 1 and minus y plus 2z equal to minus 1. We'll say let z is equal to t. Therefore, minus y plus 2t equal to minus 1 or y equal to 2t plus 1. Substitute in the first one. So, x plus 2t plus 1 plus t equal to 1. So, x comes out to be minus 3t. So, one solution is minus 3t, 2t plus 1 and t. And on the same lines we will have to find the solution for k equal to 2. So at k equal to 2, it will be still x plus y plus z equal to 1. And it will be minus y plus 2z. When you put k equal to 2, it will be 0. Let z is equal to t. Therefore, minus y plus 2t equal to 0 or y equal to 2t. And if we substitute in the first one, it is x plus 2t plus t equal to 1. So, x equal to 1 minus 3t. That will be the second set of solutions. So some typical problems are there, but they are restricted to only 3 by 3. It won't be 4 by 4. There won't be 4 equations, 4 unknowns or more अल्फा बीटा गामा डेल्टा ऐसा कुछ नहीं होगा. इट इज स्ट्रेट. राइट. Anybody has any doubt in what we are doing right now? Because this first part of the matrices is now about to end. When we start with the next part, linearly dependent vectors. See, we will come across with different names, different things, and as long as we are in matrices, everything will settle down to augmented matrix, lower triangle 0 and conclusion. Okay, so this is one more case. Now first of all, what is a vector? The vector that you might know is something like 4i plus 3j plus k वगैरह वगैरह. But vector terminology in matrix is nothing but the row matrix or the column matrix. It will be just a linear set. Okay, so vector is row matrix or column matrix. That will be termed as a vector. Okay. So we say that it is just the ordered set of elements because the positions matter. It is not the set. Set is never ordered. Okay. When you just say set of some elements, that order is not important. But ordered set is one where the position matters. In matrix, it is not the set of elements. It is set of ordered but two-dimensional elements. Here it is one dimensional. So position 1, 2, 3, they will matter. Now, suppose there are vectors, the notations that they are using are x1, x2, x3 are vectors. Now it is up to us how to think whether they are row or column. We say that they are dependent. They are linearly dependent if C1 x1 plus C2 x2 plus C3 x3 is equal to 0, where C1 C2 C3 where C1 C2 C3 are not vectors, those are values, but not all 0. Are values but not all zeros. So they can't be, all of them should be, cannot be 0. Right? What will be the other definition? Linearly independent. In that case, C1, C2, C3 will be 0. Then and then only this equation is valid. Now, obviously one has to think, suppose I have vector x1. Now here I am going to write it as, let me take the values themselves, say the vectors are given to us. Problem comes in this manner. Examine the linear dependence of, it is 2 comma minus 1 comma 3 comma 2 comma 1 comma 3 comma 4 comma 2 comma 3 comma minus 5 comma 2 comma 2. Check the linear dependence of these three vectors is the problem statement, and if they are dependent, find the relation. Got the question? Make a note till this so that I can show you the solution, how it is to be done. It is just some different thing from where you are required to create the problem and solve it. Up till now all the problems were given to us, okay, solve. You can even add here after this, if C1 equal to C2 equal to C3 equal to 0, the vectors are independent. If all of them are zeros, then it is independent. So I want to substitute in this manner. Say C1. Now I want to write the vector. I will write it in this manner. It is 2 minus 1, 3, 2 plus C2, 1, 3, 4, 2 plus C3. It is 3 minus 5, 2, 2 equal to 0, 0, 0, 0. Because there has to be the relation between all the first elements, all the second elements, all the third elements, all the fourth elements, and then only they can be dependent. So we will have to write it in this form, because when we multiply by C1 to the matrix, all the elements will get multiplied, and ultimately this will result in something like 2C1 plus C2 plus 3C3 equal to 0. Then minus C1 plus 3C2 minus 5C3 equal to 0, 3c1 plus 4c2 plus 2c3 equal to 0, and 2c1 plus 2c2 plus 2c3 equal to 0, and there we are. Now we again get the set of simultaneous equations. Now variables are c1, c2, c3, equations are homogeneous, so we will have to simply find out rho of A, because rho of A will be equal to rho of AB in this case. And that's why if rho of A comes out to be less than number of unknowns, there will be infinite solutions. If it is equal to number of unknowns, it will be a trivial solution. And if the solution is trivial, the vectors will be independent, because trivial solutions means values are 0. So here it reduces to a problem of, so this is a set of homogeneous equations. So 4 equations and 3 unknowns. If rho of A comes out to be 3, solution is trivial and vectors are independent. If rho of A is less than 3, find C1, C2, C3, or we can say find C1, C2 in terms of C3 equal to T, and substitute in C1 x1 plus C2 x2 plus C3 x3 equal to 0. So the T will cancel and you will get the relation between vectors. Of course, here the solution should not come as 2t plus 1, because then it will create problem. But otherwise that, or we will keep it in terms of T. Normally it is T, 2t, 3t, so T cancels and you will get C1 plus C2 equal to 3 times C3, like that. Okay. So now the problems which we are going to solve today are given vectors to check whether they are dependent or independent. Write them in this form. No row matrix, we will use column only, so it will be easy. And then equate element to element. So this ultimately comes out to be 4 by 1 after addition, equal to 4 by 1. So we get it. This is actually the matrix, right? This is how it is. And so we take the equations, we write the augmented matrix. Only row of A is to be found out. Row of A will be row of AB. These are the cases. In this case there are only 3 unknowns, because 3 vectors. If there are 4 vectors, there will be 4 unknowns. It doesn't matter how many elements are there in the vector. Number of vectors will decide the number of unknowns. So there were 3 vectors, 3 unknowns. If there are 4 vectors, there will be 4 unknowns. Right? Do it and tell me the relation. Question was whether this are linearly dependent, and if yes, find relation.